Hey, Algebra 2 students, this is some extra practice for your Module 1, Lesson 12. This is a typo, it should be 12b, actually 12c. No, extra practice for 12c. So this is extra practice on the lesson where we're finding solutions to cubic polynomials. Kind of took up two parts. We've been doing this for 12b and 12c by grouping. And then we also want to be able to find solutions using other methods, because we'll find we'll also need to use maybe difference of squares or some other methods to find our solutions. All right, so again, for this intervention work, you're going to be going through the summary with me with the notes, taking notes on this front page, maybe trying out this example and walking through it. Then on the back side, there's 1, 2, 3, 4, 5, 6 problems for you to try out and practice to really nail down the skill. And then you make sure you correct your answers with your intervention teacher at the end. Okay, so for our summary, we're going to look at this question. I'm going to come up with one right now. I'm going to come up with the question 2x cubed plus 4x squared minus mine is 3x minus 6. So that's the polynomial we want to factor. We know it's a cubic polynomial, it has degree 3, and this grouping, this will be the only way we know how to factor this kind of polynomial. So if you're ever asked to factor a polynomial that has degree 3, we know we're going to want to be using this method. All right, so our first step is going to be look for groups that have common factors. So typically what I do is I just pick, I pair them off into two groups. One group from the left side with my cubed term and my squared term, one group from the right side with my x term and my constant term. Now our job is to come up with what common factors go into both of these terms. So the way I like to think about this is I'm trying to think of what factors go into 2x cubed and into 4x squared. And I like to break it down just by the numbers. So I'm looking for numbers that go into both 2 and go into 4. I know 2 goes into 2, and 2 also goes into 4. And I won't be able to do anything bigger than that. So I know at least one common factor. My greatest common factor here is going to be a 2 for the numbers. Now let's see if there's any factors for the x's. So for the x's, there are 3 x's here. That's the same as x times x times x. And then in the second one, 2 times x times x times x. In the second one, it has, we'll split it all the way down, 2 times 2 times x times x. The second one has 2 factors of x. So when I'm looking for what's common, I want to look for things that are the same between the two of them. So I see, after I've split this up, there are at least 2 x's in both of those terms. And I also see there's at least 1 2 in both of those terms. So overall, the greatest common factor is going to be a 2, like we already found. 2 is what goes into both. And an x times an x, or an x squared. So the greatest common factor between these two is going to be a 2x squared. Then what we want to do with that greatest common factor is we want to pull it out, to divide it out of this whole term, of this whole binomial, both of those pieces. So to do that, I'm going to rewrite it just down below, 2x cubed plus 4x squared. Now we know we want to pull out a 2x squared. So we're going to divide out a 2x squared from both of these terms and then pull it outside of our thing and multiply it on the outside. So this doesn't change our quantity at all, but it does allow us to pull that greatest common factor out. If I rewrite this, 2x squared on the outside. Now I'm just doing a division problem. 2 divided by 2 is going to be a 1. X cubed, let me highlight this so you can see 2 divided by 2 is going to be a 1. X cubed divided by x squared, well there's 3 x's on top and 2 are being divided out. So that just leaves me with 1 x left over. And then plus 4 divided by 2, do the same thing, 4 for the numbers divided by 2 is going to give us 2. And then for the x's, an x squared divided by an x squared, anything just divided by itself is going to be 1. Another way we can think about it, it's going to be x to the 2 minus 2, which is going to be x to the 0, which is 1. anyway, they divide to 1. So that's just going to be a times a 1. That doesn't really change our value. So what we did is we picked out a factor that goes into both of these terms, both into the first and second term, a common factor, and then we factored it out. The way we did that is we divided it by both terms and pulled it out front, kind of like we're distributing backwards. It's like instead of distributing our term through, we're dividing it out and pulling it out. And then we simplified that, and we ended up with a term. So hopefully, if we do the same process on this other side, greatest common factor on the right side, divide it out, we should end up with a very similar group down here that would allow us to simplify this and factor it. So let's look. Looking between these two terms, I see a -3. I like to pick my numbers first. A -3 is going to be my coefficient, and a -6. So I'm looking for common factors of -3 and -6. Well, 3, the only thing that goes into 3 is either 3 or 1. So does 3 also go into 6? Let's see. 3 goes into 6, yeah, twice. And both of these are negative. So I actually can take out a negative for the coefficients. I'm going to put it over here. I'm going to take out a -3. That is a factor that goes into both of those terms. And then for the x's, I only see this one x here. And there's no x's in the second term, in my constant term. So there's no x thing. So I think our greatest common factor for this part, this group, is going to be -3. So we're going to do the same thing. I'm going to rewrite it down here. -3x minus 6. And what we're going to do is we're going to divide out our greatest common factor of -3. Divide by -3, divide by -3. And then pull those, like undistribute them. It's the inverse of distributing. We're factoring them out into out here. So -3 is going to come up out front. A -3 divided by a -3, again, now we're just dividing. A -3 divided by a -3 gives us a 1, positive 1. Again, anything divided by itself will always be 1. And we also have an x there that nothing happened to it, still an x. The second term, -6 divided by -3. A negative is going to make a positive. 3 or 6 divided by 3 is 2. Okay. So what I'm going to do now is kind of clean up this work we've been doing. Notice here it said step 1, look for common factors. We did that, and we got our greatest common factors of 2x squared and -3. And then step 2 is to divide out those common factors to make the same groups. That's what we did here in this step when we divided out a 2x squared and a -3. Now in step 3, we're going to do this thing to factor out this larger group. So I'm going to rewrite this 2x squared. I'm just going to write this as 1x as x plus 2. And then we have -3 and x plus 2. So looking at this structure again, I see there is a common factor between these two of x plus 2. X plus 2 is being multiplied by the first term, and it's being multiplied by the second term. Well, just like we had up here, when we had common factors, we could factor them out. We could divide them out and pull it to the outside of our overall group. So I'm going to treat this as one bigger group. And we're going to do the same thing. We're going to divide out our x plus 2, divide out this common factor of x plus 2, and pull it out to the front of this. So x plus 2 out front. And then what's left after we've divided these out? Well, if I divide out an x plus 2 divided by an x plus 2, that's just going to divide to 1. It's a big 1. And x plus 2 divided by x plus 2, again, anytime we have something divided by itself, that's just going to be 1. So after we've done the division, all that we have left is our 2x squared term and our -3. So this process has a lot of steps. Once we've gotten to this point, this is the factored form. So we've factored our cubic polynomial. Our goal is going to be now to find solutions. So say we had an equation that was like, find the solutions of this original polynomial. What we would do is, they would be, or maybe zeros, we would be setting this equation 2x squared minus 3 equal to 0, and then we need to go on and solve. Once it's factored though, it's really easy to find solutions because of our zero product property. We know that something times itself, or any two things multiplied together equals 0. That means either one of them is 0, so either x plus 2 is equal to 0, or 2x squared minus 3 is equal to 0. So once we're looking for zeros, once we have it factored, we know that either factor could be 0 since they're being multiplied. X plus 2 equal to 0. To solve for x, we would subtract 2, x equals negative 2 would be one solution to this polynomial. And this other one here, we could try and do a similar approach and just solve this equation. Let's try that. I want to get rid of maybe this negative 3 first, so I'm going to add 3. Then I just have a 2x squared equal to 3. Now I would like to get rid of this 2 next, so it's being multiplied by x squared, so I'm going to divide it out, and we get x squared equal to 3 over 2. Now the only thing that's left in the way of me solving this x by itself is that squared. And so just like back here when we had a negative and a positive, those are inverse operations. We use the inverse to get rid of the 3. If it was a minus 3, we added 3. Just like with the multiply and the divide, if we had a 2 multiplied, we divided by 2 to get rid of it. The inverse operation for our square is a square root. So anytime we have a square we want to get rid of it, we can take a square root. The only thing we have to be careful with square roots is when we take square roots, there are 2 possible answers. Either we could have 2 positive numbers that are being multiplied together, square root of 3 all over 2, or we could have 2 negative numbers that are being multiplied together to make 3 halves. So the only thing that's a little bit new in this lesson is that we can solve problems like this using just our normal algebra skills, solving like a 3-step equation, adding, dividing, and we can take a square root. But we have to remember that either we get a positive solution or a negative solution. Another way we could check ourselves if we're like, I wonder if I should make it positive or negative. We know that this is a squared equation, right? This polynomial is a squared. It's a degree 2 polynomial. So it should have 2 solutions. So that's why by the end we need to make sure we consider a positive and a negative solution to that polynomial. All right. So this process has a lot of steps. Once we start getting practice with it and getting more fluent, it comes pretty easily though. So what I want us to do down here for this example, I'm going to get us started on it, and then later I'll release us to practice it, and then we'll come back and check it out. Again, step 1, we just want to group terms that have some common factors. So I usually just group the first 2 and the last 2. I'm going to rewrite them here. Negative 3x cubed minus 6x squared. That's one group. Another group is 4x plus 8. Again, now we want to find our greatest common factor for each of these. Once we find our greatest common factor, that's what we're going to be dividing out, and hopefully we get the same terms we did up there. When I do this to find my first common factor, I want to think about what's a common factor of the coefficients. Oops, this was a negative 3. What's the common factor of the coefficients? So negative 3 and negative 6. That'll be part of our greatest common factor. What's the greatest common factor of our x values? And do the same thing for this other one. What's the greatest common factor of these coefficients over here? And is there a common factor for our x values? All right, so pause the video at this point, take a second, look back at our example, try and remember how we got the greatest common factors, and then see if you can divide them out, and you should end up with this nice form where we have a binomial, something like x plus 2 in this example, that's really easy, multiply by two numbers, then we can pull it out multiply. So pause the video, try this out, and then when you're ready, when you need to check yourself, start it again, and I will walk through it. All right, so hopefully you've tried this out. We're going to look at the first term. If I'm trying to figure out the greatest common factor between my two coefficients, my two numbers, -3 and -6, the only thing that goes into 3 is 3 and 1. Does 3 also go into 6? Yes. So I think a 3 goes into both of these, and in fact, a -3 is in both of these terms. So I'd say there's a -3 common factor in the coefficients. And then for the x values, the first one has 3 x's being multiplied, the second one has 2 x's being multiplied. So we can take out at least 2 of the x's, right? If we took 2 away from this one over here, if we took 2 away from the right one, all those x's would be gone. If we took 2 away from this one, there would just be 1 x left. So we can take out 2 of those x's like that. So that'll be our greatest common factor. Let's quickly factor this out. So our -3x squared is our common factor. It comes out. Then we divide by it, -3x squared, -3x squared. We get -3 divided by -3 is 1. X cubed divided by x squared is x. So 1x. Over in the second one, we get 6 divided by 3 is 2. Negative and negative is positive. Yep, so positive 2. And then x squared divided by x squared is just 1, because anything divided by itself is 1. And so really we're just left with x plus 2. So we have a common factor of x plus 2 in this one. Now we got to do the same to the right side. So a little more quickly this time, we're seeing factors that go into 4 and into 8. Well, 4 goes into 4, and 4 also goes into 8. So 4 is a big factor that goes into both. And there's no x factors, right? X is just in the first one. There's no x factors in the second one, so we can't split that one up. So again, we're going to write our common factor down here, pulled out. We got to divide by our 4, divide by our factor. 4 divided by 4 is 1, so that's going to be x. 8 divided by 4 is just 2. Nice. So here we have, this is kind of like the end of our step 2. We have this group of x minus 2 in both of our terms. So again, we can think of this as another common factor, and we want to pull that common factor out. So this big group here, we're going to pull out our factor of x plus 2. So that means we're going to be dividing it out of both of these, dividing it out of both of these. When we divide it, they just turn to 1, so effectively they don't matter in this product anymore, so we just have -3 x cubed plus whatever's left over from this one, which is 4. Sorry, x cubed? No, it should be x squared. That was just a scribble. 3x squared plus 4. And it told us originally to find the 0, so we're trying to find the values where this thing is equal to 0, or it's equal to 0. So that's the factoring work done. Now we're just solving these equations. So again, either x is going to be equal to 2, or x plus 2 equals 0, or -3x squared minus 4 equals 0. So x is going to be -2 in this case. On this side, this is a plus 4. I'm going to subtract 4. Subtract 4, -3x squared equals -4. I'm going to solve this some more. Now I can divide by then my -3. That's the inverse of multiplying by it. And we're left with x squared equals -4 divided by -3. Well, that's just going to be a positive 4 over 3. And then now again we have this square left over. To get rid of it, to undo the square operation, we got to take a square root. So either we're going to get x equal to a positive square root of 4 over 3, or x equals a negative square root of 4 over 3. Okay. And again, you could put these in a calculator if you wanted. Square root of 4 over 3 would be some decimal. So you could write it as a decimal if you wanted. Otherwise, you can just leave it like this, but just know that you could do it both ways. So that's kind of an overview of how we can use this grouping method. It does have some steps, but I encourage you to practice it first just by grouping our terms. On the back side here, I would group these to start. I would look for factors that are in common between them. For this one, it looks to me like they have, just looking at it, 8 and 64. Well, 8 goes into both 8 and 64, so 8 is going to come out. There's at least 2 r's in each, 8r squared. Then I want to divide these by my 8r squared. And that leaves me with something. And on this right side, common factors of 1 and negative 8. Well, there's not a lot in common between 1 and negative 8. I think really just 1, right? Really 1 is going to go into only r8. And then there's no r factors. So this is I just kind of got us started on this next one. I want to be able to divide out those factors. We should get something that's similar, rearrange it, and solve for our solution. So our practice, find the zeros of these. Notice that 2 and 3 are the same question, so we really only have to do one of them. So you really just have 1, 2, 3, 4 problems to practice, and I started us on this 5th one. So try these out. When you're ready, check your answers with your intervention teacher. Talk to people who are working on the same problem, and then you'll get your credit for this extra practice.